Okay, it says what's the mathematical definition of a triangle? Okay, we all know what triangles look like, but what are we going to say? How would we describe a triangle to, let's say, a younger kid who doesn't know what a triangle is? Yeah. Three-sided, okay. The angles add to 180 degrees. What else? What about all those sides? The sides are all... Okay, if we say it's three-sided, three-sided what? Polygon. Okay, polygon means that the sides are closed. There's no open side, right? So let's be a little more specific and say three-sided polygon. The sides are all closed. They all meet. Okay. How many angles does it have? Three angles. So three sides and three angles. Okay, very good. And that's what we would say for a triangle. And then we have some different names for different triangles. If all three angles of the triangle are acute, we call it an acute triangle. What does acute mean? Acute means less than 90 degrees. So that means all of these angles have to be less than 90 degrees, and then it's called an acute triangle. If it has one triangle that equals 90 degrees, it's called a right triangle. And if it has one triangle that is, one angle that is more than 90 degrees, obtuse triangle. Why can't it have more than one angle that is more than 90 degrees? Okay? Think if I have one angle more than 90 degrees, I already have 90 degrees or more, right? If I have another angle that's more than 90 degrees, let's say they're both 91 and 91 degrees. How many total degrees is that? 182. And how many degrees are in a triangle? Is that even possible to have 182 degrees in just two angles then? No. Okay? So if it's an obtuse triangle, it's only going to have one angle that's more than 90 degrees. And these two are going to be less than 90. Right? Okay? Same with a right triangle. I can't have two angles. Thank you. I can't have two angles that are that are 90 degrees, because what if I have two angles that are 90 degrees? What does that add to? 180, and I've only used two of my angles. I have another angle. How many degrees are left for that third angle? 0. And you can't make an angle with 0 degrees. So you can only have one right angle, and you can only have one obtuse angle for those triangles. Okay? If I name them by the sides, if all three sides are the same length, equilateral. Okay, equal. All three sides are equal. Two sides are the same, isosceles. And I'm sure you've heard these names before, correct? Okay. And none of the sides are congruent, scalene. Okay. I mark sides that are congruent by these tick marks. Okay. Same with angles. Okay, all three of these angles are congruent. I know that because it just has one arc. These two angles are congruent to each other. They have two arcs. So the angles that have the same amount of arcs are the congruent angles. The sides that have the same amount of tick marks are congruent sides. Okay. E and D is congruent to FD. In that isosceles triangle. How do I know that bottom left is isosceles? Look at this triangle. How do I know this is isosceles? There's two sides that are the same length. Okay? What would you call this one? equilateral. And what are those angles going to be if it's equilateral? They're going to equal 180, but what has to be true about those angles? They're all the same, so what are they going to measure? Three of them have to add up to 180, and they're all going to be the same. Here's a math problem. Correct. 60 degrees. So then if you named it by its angles, that equilateral triangle is going to be named what? Acute. Because all three sides are less than 90. So it's an acute equilateral triangle. Okay? Naming it by both. Okay, so we're going to find some missing numbers, and then we're going to name them. It says find the value of x and classify it by its angles. Okay, so I have 42 degrees, and the missing side. What might I do to find that missing angle? Okay, so add 42 and 42 together. And that's what? And I take that from 180, and I get 96. Okay, so naming it by its angles. What would the name be if I named by its angles? That's by sides. You'd have two congruent sides, yes. It would be isosceles by sides, but by angles, what's the name? Why, Kim? It is obtuse, but why? It has one angle that's bigger than 90 degrees. Okay, so when it has one angle bigger than 90 degrees, it's obtuse. Named by its angles. So you have to know the three names for angles. You have to know the three names for sides. Okay. Questions on that one? Okay. It says the measure of an exterior angle is related to the interior angles of a triangle. This should be something that shouldn't be too difficult for us. Okay, I want you to find now the measure of angle x. What do you know about 68 degrees and angle x?
They're going to be 180.
Why are they going to be 180? It makes a straight line. Okay, so if it makes a straight line, they add to 180. What do I have to do to solve, Evan?
Just take 180 minus 68 and together.
Okay, very good. And that's what this says. 68 plus x has to equal 180. So if I just subtract 68, we'll find that x is going to be 112. Okay. Let's just practice this triangle. What is it going to be called? Let's name it by sides and by angles. What's it going to be called? Acute. Why is it acute? All less than 90. And by the sides? It's scalene. Why is it scalene? All of them are going to be different. The reason I know all of them are going to be different is because all of my angles are different. If all of your angles are different, all your sides are different. Okay? Very good. A scalene acute triangle. Okay, very good. Questions? Okay. Now it says find the measures of CBD and CDB. Okay, now it's a little confusing, but remember how I said we're going to look at angles that are named with three letters. So you have to be able to find CBD. I put my pencil at C. And then I go to what? B, and then I go to D. So what they want me to find is this angle. So really I'm finding B right there. How do I find B right there? How am I going to, 76 plus what?
It's a 180 now.
Okay, look at this. It's a straight line, makes 180. So I take 180 minus 106 and we get 74 degrees. Okay, so angle CBD, 74 degrees. Okay, now they want us to find CDB. So how do I figure out what angle I'm trying to find? I start where?
The middle one.
C, and then I go to D, and then to B. So I'm trying to find right here. How might we find that? Okay, we have a triangle, right? And I have two angles already given to me, and I know in a triangle there's 180 degrees. So I add 76 and 74 together, and that gives us 150. So then 180 minus 150 gives us 30. What kind of triangle is this? Let's name it. Acute, because all angles are less than 90. And how about by the sides? Scalene, because all three sides are going to be different, because all angles are different. Very good. Okay. Another thing that we're going to do is now we're going to look at two different triangles, and we're going to say, are those triangles similar? What does similar mean again? Same shape, different size. And triangles are going to be similar if they have two angles that are the same. Okay? Two angles have to be the same, and then they are going to be similar. So if I look at this, here's two triangles. Are they the same size? No. Do they look like they might be the same shape? It's possible. So it's possible they could be similar. In order for them to be similar, okay, we find angle-angle similarity. That means two angles have to be the same. Do you have one angle that is the same? The 90-degree angle in both of them. Okay, so there you have one pair of angles that is similar. Now you have to find another pair. You need two pairs. Okay, well, are 39 and 51 the same? No. So now I have to find this one and see if those are the same as any of my other ones. How might I do that? Okay, you could do 90 plus 51. We get 141. 180 minus 141. We get 9 and 3 and 0. So we get 39. What does that tell us? This is the same, and this is the same, right? Okay, so do I have two angles that are the same? Then these two triangles are similar. Okay? Are two triangles similar? Yes. We have two pairs of congruent angles. Okay? As long as you have two pairs of congruent angles, they are similar. Okay? Questions? What we're looking for? What are we looking for? Similar triangles by looking for congruent angles. Okay? They say, are the two triangles similar? And then how do you know? So triangle RSW and then VSB. Do we have one pair? Yeah, that's easy to see, right? We have to find another pair. Can I find anything else? What can you find? Tim? Where the lines intersect here? What do you know? This angle and this angle? Why do you say they're the same? They just are. I don't take answers that say they just are or they just look like it. Hannah? There we go. Okay? This angle and this angle are congruent because they are vertical angles. And what did we say about vertical angles? They are always congruent. It does not matter if the lines are parallel or not. Vertical angles are always congruent. So does it matter if I know what the angle number is? No. All I care is that it's the same. And I know they're the same. I don't care what number it is. Okay? So are they similar then? Yes, they're similar because we have what? We have two pairs of congruent angles. Okay, the next pair of triangles, JKL and PQR. Okay, we got 70s. We got two 70s, so that's one pair. How might I find the missing angles? Add and then subtract. Okay, 70 and 30, add to what? And 180 minus 100. Okay, do I have another pair? No. Okay, so then I better check over here. 70 and 85 is how much? 155. And that gives us 25. Do I have another pair of congruent angles? No. So are they similar? No, you need two. We only have one pair of congruent angles. Okay. Questions? Angle-angle similarity is what we're looking for. And we have three more that we're going to look at here. And I'm not giving you any angle measurements in these first two. Okay. First one. Are those two triangles similar? Where is your pair of congruent angles then, if you say they are similar? Okay, the vertical angles again. That one, we talked about that one. So those are congruent. What do these two arrows tell you? Oh, those two lines are parallel. Okay, and what do we know about parallel lines cut by a transversal? We can find a lot of different angles, right? Okay, so if I extend my parallel lines and I extend these transversals, can you find any other angles? Where's 90? No, we don't know because there's no box drawn in there, right? Remember, you have to in order to know it's 90, you have to have that little square drawn in. What if I erase the line from A to D? Erase that line from your mind. Okay? So now, if I redraw it, it looks like this. Okay? And here's angle B, And then here's angle C. Okay? I erased A to D. Does everybody see that? If I erase A to D and I redraw it, can you tell me anything? Dylan? Okay, alternate exterior. These angles are congruent. But are those angles in the triangle? No. But what do you know about this angle and this angle? They're vertical, and what are vertical angles? Congruent. So if C is congruent to B, that means their vertical angles are what? Also congruent. And what are these angles called? Those are alternate interior angles. We're looking at this angle here, and we're looking at this angle here. Those are alternate interior angles. And what do you know about alternate interior angles? They're congruent. Okay? So did I find two pairs of congruent angles? Yes, we did. Okay? You can say angle, angle, similarity. So we found two pairs of congruent angles. Okay, how about the next one? We have two triangles, one inside the other. Okay, so you see our big one is LMN, and our little one, PON, or OPN. Okay? Do you have one pair of congruent angles? Well, what's the easiest one to say is congruent? Listen to the name of my triangles. LMN, OPN. N is in both of them, right? So N has to be congruent to itself. So that's in both triangles, that's got to be congruent. Okay? Do you have another pair of congruent? Huh? Why do you say L and O? Okay, so if I extend parallel lines, I always like to extend parallel lines so I can see things. If I extend those, now what? You have this transversal. This is a transversal, right? You have L and you have O. Good job, Dylan. Those are corresponding angles, and corresponding angles are always congruent when you have parallel lines. Okay? So again, we have two pairs of congruent angles. So we have angle-angle similarity. Okay, so we're using what we learned the last 2 days about corresponding angles, vertical angles, alternate interior angles. Okay? Now you have to use that to help you find if these triangles are similar or not. Okay, and then the last one. Do we have one pair? 76 and 76. Okay? Now we have to find if we have a second pair, and what will we do to do that? Good. Add and subtract. So which one do we want to do? 76 and 48? Add those, we get 14, 124. 180 minus 124. Does it give us 63? No. So we don't have two pairs. Only one pair of congruent angles. Okay? So what I want you to do by Friday, you're going to have H17 finished for me. Okay? Yep. Because you have scuba the next 2 days. What?